Welcome, I'm Adam Beasy, Assistant Professor of Advanced Manufacturing at Vincennes University. In this video, we'll learn about and create a robot's tool center point file, or TCP. This is an important coordinate for every programmer to understand. So, what is a TCP? A robot's TCP determines the exact point at which the robot's end-of-arm tooling will perform its work. The robot's tool coordinate is one of three coordinate systems that use the XYZ coordinate system to manually move the robot. To help the programmer identify the XYZ coordinate planes, they can use the right-hand rule. The direction of the index finger is the positive X plane. The direction of the middle finger is the positive Y plane. The direction of the thumb is the positive Z plane. Your elbow is in the direction of the robot cables. When using rectangular coordinates, the TCP will move in a straight line using the right-hand rule in relation to the robot's base origin. The robot's TCP uses the right-hand rule as well, however, not in relation to the robot's base origin. By default, it is now in relation to the center of the T-axis flange. Because the T-axis can change its orientation, the right-hand rule is now relative and is a floating coordinate system. It will change with the position of the tool. Teaching or manually moving the robot with the correct tool frame will reduce the programmer's teaching time. The proper tool frame adjusts the XYZ coordinate plane if the tool orientation changes. This is highly beneficial when teaching on complex parts whose contours change. If the programmer didn't use the tool coordinate when teaching a complex part, they constantly switch between rectangular and joint coordinates, which causes constant adjustments of an individual axis along with the XYZ coordinate plane whenever the orientation changed, which takes significantly more time to teach the robot, as well as making it more complex. Selecting the tool coordinate frame is different from selecting the tool coordinate. Selecting the tool coordinate tells the robot what type of motion to take. The tool coordinate frame, or tool file, tells the robot what tool type is attached. One tool file could be for a welding torch, another for a gripper, and another for a suction cup. Each tool will have a different point in space where work will be performed. Because each point is different, each will apply the right-hand rule at a different location in space. Selecting the tool coordinate tells the robot to look at the active tool file being used. The tool frame file can be set up in two ways, manually or with the tool calibration utility. Here are two things to keep in mind. If the tool dimensions are known or have been accurately measured, the programmer can manually enter the X, Y, Z, RX, RY, and RZ distances. If the tool dimensions are unknown, it's easier for the programmer to calibrate the tool using the tool calibration method. To create a tool file, choose a fixed point to teach the tooling to. In Teach mode, from the main menu area, choose Robot. Choose Tool from the submenu and select the tool number to set up by highlighting the tool number and pressing the Select button on the Teach pendant. Choose Utility in the main menu. Then choose Calibration. This method to set up the TCP requires the programmer to teach 5 different points, TC1 through TC5, each with significant differences while keeping the center of the tool at a fixed location. Move the robot to the first location and select position TC1. Press Modify, then Enter to record the point. Move the robot tool to the second location with the center of the tool as close as possible to the previous point. Select position TC2. Press Modify, then Enter to record the second point. Repeat this procedure for TC3 through TC5. Then press Complete when 5 points are taught. Once a tool file is created in the tool coordinate list, the programmer must select the correct tool file. The robot can have up to 64 different tool files available. Hold down Shift plus coordinate to bring up the tool select list. Cursor to the tool file you would like to use. Then hold down Shift plus coordinate again to select the tool file. After selecting the tool file, the programmer should test the active TCP to verify the proper setup with the robot and the tool coordinate system and the appropriate tool file selected. Manually move the robot's minor axes around the fixed point in space. The center of the tool should not drastically deviate from this point. In closing, here are a few things to remember. Using the robot's proper coordinate system will reduce the time needed to teach the robot's motion. While in tool coordinate, the robot's TCP is a floating coordinate system that will change with the position of the tool. The programmer can easily set the tool center point by using the tool calibration method. After the tool center point is set up, test the tool by manually moving the robot's minor axes to verify minimal movement from the center of the tool. Thank you for joining me to learn how to create a TCP. Look for other videos about robotics and advanced manufacturing.